Our next speaker once had to be rescued in the middle of the Pacific Ocean when the dive boat she was on sank. Yes, she's here with us now, so clearly she survived. Melissa.
So yeah, it works on my machine. Reproducibility and R for small teams. So some of you, if you're Microsoft shops at work, probably recognize this sticker from Teams. It's my favorite one to use when I just can't deal with all the problems anymore. And I think it says a lot that it's stock imagery in the Teams chat. So a few disclaimers before I get started. I work for New York State DEC, the Department of Environmental Conservation, but these opinions are my own and do not reflect any agency policy. And also everything but that first image was generated with Adobe Firefly. So some of them are a little weird, and that's why. Okay, so about me. I am not a computer programmer. I am not a software engineer. I don't do statistics. I'm a marine biologist. And that's a pretty cool job title. It starts a lot of conversations, and people have a lot of ideas about what it means to be a marine biologist and what a marine biologist does. So, people think we work at SeaWorld, or we're out swimming with dolphins, or on a research vessel out in the ocean for, a week at a time. And that is Adobe's rendition of a NOAA research vessel. It's okay. But there are many people who do that work as a marine biologist, but I'm not one of them. I get super seasick, so that is not the work for me. So what I ended up doing is working with fisheries data. So this means mostly catch and effort, like who's fishing where, when, how, and how much they're catching. And I can do this all safely from my cube on land, where I don't have to worry about severe motion sickness. But what it means that I do is the same thing most of you probably do: a lot of data cleaning, getting the data to the people who need it, running my own analysis, and then writing lots of reports. And I use R for most things I do at work these days. Obviously, I'm using it to automate everything. There's so much you end up doing, and if you have to do it more than 3 times, you might as well automate it. And I hate doing repetitive work anyway, so that's worked out really great. But most recently, I've been enjoying using it to generate all of my reports. So often we have to run, thousands of individualized reports at a time, where they're drawing from multiple data sources, and the content of those reports is very specific to the individual. Certain sections might apply to one individual, but not another, and I don't want to have to separate those people out first. And this has been like a huge success and saved a lot of work. Everybody loves it. But I'm not actually going to talk about that today. What I want to talk about is what happens when you have that success. You've created this thing, you've proven your concept, it's in production, and now what do you have to do to keep it going? Before we get into it though, for the purposes of this talk, a small team is around 10 people or less. And I'm going to add the caveat that they have limited to no experience with R. Many people are trained in something else and find that they have to learn, how to code to do their jobs effectively. So they're coming from, biology, ecology, chemistry backgrounds, but they have to learn these tools in order to really succeed at their job. And often there's no enterprise tools, there's no IT resources to devote to this. It's no enterprise R studio and any of the tools that go with it. It's all local on your machine. Maybe you have a shared file server somewhere. All right, so you've done all this stuff. You made this new thing, you're really proud of it. It's in production. Now you have to share that workload amongst your team, because you can't be the sole person who maintains this forever. It's a terrible feeling being the bottleneck when everybody's waiting on you to get something done. Or, if you come back from vacation full of dread because you don't know what happened while you were gone. So what happens after you implement this big change? Who's responsible for the maintenance, and who's responsible for making new features? So after a lot of Googling, I found that the consensus was I should be using R projects. I should be using GitHub. I should be creating my own packages. And there's also a lot of the information out there about RN. I don't even know how to pronounce that. They should have made that easier to say. And of course, after reading all this information, no one seemed to have any problems with any of this on the internet. And spoiler alert, I did. Nothing worked the first time, the 10th time. I did all the things. I sent my projects off to coworkers to try to run, and it was a huge failure. It took several tries through to get anything to work. You know, we saw all the classic errors. There's no packages. There's no data. They can't find your file path. And you don't have the right permissions. And when you're working with, you know, a team that is newer, isn't as experienced in R, that can all be hugely frustrating and really prevent them from kind of buying into this these new set of tools. Mostly people who had experience with R or Python could debug in real time and get it to work, but you shouldn't have to. It should be seamless. All right, so I'm going to go through all those things I just mentioned, the problems I had with them, some approaches I took to try to mitigate those. I also decided I was going to learn Quarto for this presentation, so that was just an extra challenge to throw in there. So our projects. This I thought was like a base level of knowledge that anyone who was using R had heard of, and that did not turn out to be the case. Most issues we had with our projects were people not using projects as they were intended. So people didn't understand that it was more than just a folder, that it had all this special information that, you know, helped R find things and keep track of your history and all these bonus things. And I would find staff in the worst case scenario, just opening scripts from several different projects, trying to run them in no project, and everything was failing because R couldn't find anything. Or they would bring in scripts from other places to their project, and again, R couldn't find everything, so it would fail, and they would get frustrated. So, you know, unsurprisingly, you know, they weren't feeling good about what they were doing, you know, with the team. And the only way around that, unfortunately, is to just, you know, train your people better and making sure there's onboarding in process and continued training so that they know what you know. And as I mentioned, you know, relative paths are great. And for ad hoc analysis, sometimes an R project is all you need to be able to run it quickly on somebody else's machine if it's something that you're never going to do again. You know, next we started using GitHub and GitHub repositories. This had a significant learning curve, and the workflow involved in GitHub, remembering to, you know, fork a project, sync your project with the main project, or sync your repo with the main repo to make sure you're getting changes, was very alien to people who aren't coming from that type of workflow normally. So we would run into lots of problems just with behaviors and remembering to do this. So again, things wouldn't work. And every time something doesn't work, people get discouraged. And that's definitely not what you want on your team. However, once people got that workflow down, it was the easiest way to get code onto somebody's machine. And the most important piece of it is when they fork a repo, they can do whatever they want to the repo without ruining everything. And it's so important for people to have room to mess up colossally and have it be okay. Otherwise, people aren't going to be willing to help you maintain things and build new features going forward. Excuse me. So after that happened, I decided it was time that we make our own package for our office. And this was really intimidating, and it still has the same problems of keeping everything in sync. You'll hear me say that on every slide. Having the same thing for every person all the time has been really tricky when you don't have you know, larger scale IT resources to help you out. And then who's going to maintain this package forever? Because once you become dependent on it, if it breaks, are you going to go back to Excel? I hope not. And it also allows me to assign more work to other people. So perhaps before I was the only one who could do certain analysis because I knew I had to look here, here, and here and filter it this way to get the right data set. But now when we put it in a package, everybody can do that. So everyone's treating the data the same. They're starting with apples to apples. And I'm sure a lot of you have the same experience that 90% of what you do is the exact same thing everywhere. So if you can make that easier, that's a huge time saver and reduces your own errors as well. Lastly, we're trying out our renv, and we've had constant problems with package versions on people's machines. Depending on when someone is hired, they might have a different version of R, hundreds of different versions of packages combinations on everybody's machine. We're not supposed to install all that ourselves. IT is supposed to do that, but you can't tell IT what to do. And you end up with a situation where everybody's just confused and nothing works. So we've picked a few projects to start trying this out at, and this has been the hardest thing about R that I think I've ever done, getting this to work properly. This might be our own system. I'm not really sure, but it's so slow to boot up. Like if I ask someone to run this project, they clone it from GitHub. By the time RStudio is done installing all the parts of that renv lock file, it could be an hour. And my projects aren't that big. We're not big data. And that's pretty frustrating. Oftentimes, staff will have to do something else while it's running and have to shut it down. And it's just a bad feeling, again, when you're trying to get new people on board and to feel successful and want to help you move forward with things. We also ran into issues where staff were updating the lock file themselves, which defeats the entire purpose. They should be using the packages that I developed the project with, but then they were switching out and just overwriting their lock file, so things weren't working again. So this is still a work in progress, but it has helped me write better code in the sense that I shouldn't use renv until I'm almost done with the project. When there's so much in flux, it's not really helpful when it's just me working on it anyway. And it's also forced me to minimize the amount of dependencies I use. So there's less room for mistakes if you're pulling less packages. So my main takeaways when you're working on this small team that doesn't have a budget or support, and you're trying to move forward and do new and innovative things in R or even other software platforms, is that you can't ignore documentation, training, and being consistent about it. What you say while you're talking to someone, they're not going to remember. It has to be written down somewhere. There has to be something they can fall back on if you're not there. You also need to simplify everything whenever you can. As you're working on projects, you might try things and the remnants of them are still there, and those things might not be necessary anymore, but they're still causing problems. So you need to get rid of all that stuff that's not important and keep everything focused on the actual point of the project. And lastly, it's important to avoid scope creep in your projects. I might start a project with this one analysis in mind, but someone asked me a slightly different question, but I can cheat by going back to this analysis, and then I keep building on it and things get messy. And you just, again, run into more problems. It's harder to break it away when it's time to run an analysis that you need in 15 minutes. So what's our next step after this? So I'm recently experimenting with containers. I normally have always thought of things like Docker and Podman as being kind of a large IT issue that I would need a lot of help to roll out. But honestly, working this has been just as frustrating as RN. So why not? And all the code I've been talking about previous to this slide has been code that I wrote that I want other people to run and maintain. But I also would like other members of the team to start writing their own code. And I think a container is a safer, more friendly way for them to do that, where everything that they need is set and there's just less ways that they can run into mistakes. I didn't put this on a slide, but I'm just going to throw it out there anyway. Of all the problems we've had, we have never, ever had a problem with a Shiny app run locally. I don't know why, but we've been running some apps for years and there's never been an issue. Whereas other projects that are less complicated seem to constantly have hit snags. So I don't know why, but perhaps I should be writing more things in Shiny. So that's all. Thank you for listening. All my slides are on my GitHub. It's Hegeman and the repo is 2023_rgov. You can also find me on LinkedIn. It's Melissa Albino Hegeman. I'm the only one there. Yeah, and I look forward to talking to you guys later and hearing about your own struggles working with your coworkers in small teams. Thank you.